Hey guys, welcome to yet another interesting session by Intellipaat. We'll start off by understanding what exactly is artificial intelligence. Then we'll look at some applications of artificial intelligence, following which we'll look at different languages to implement AI. Further, we'll understand the concept of deep learning. And finally, we'll work with Tensorflow. So let's start a journey. So this is Jake, who stumbles upon terms such as artificial intelligence, deep learning, and neural networks, and starts wondering what exactly is AI. So he goes to Uncle Charlie, who is an AI expert, to get a good grasp of artificial intelligence. Now, Uncle Charlie asks an interesting question. What makes humans intelligent? Really an intriguing question, isn't it? So, what is it that makes us intelligent? Jake thinks for a while and states that we as human beings can think, learn, and make decisions. And that is what makes us intelligent. And Jake is absolutely right. Now, Uncle Charlie asks, can machines show human like intelligence? Machines which can think and learn like humans. Sounds amazing, doesn't it? And this is pretty much the underlying concept of artificial intelligence. So, simply put, artificial intelligence is the field of developing computers which can perform tasks requiring human intelligence. So, now that we've understood what exactly is artificial intelligence, let us look at some of its applications. AI is used extensively in the aviation industry. NASA has created an AI-based software that enables a damaged aircraft to continue flight until a safe landing zone can be reached. This software compensates for all the damaged components by relying on the undamaged components. AI has various applications in finance as well. Complex AI systems are used to make trading decisions at speeds of several orders of magnitude greater than any human is capable of, and this helps in making millions of trades in a day without any human intervention. Now, would you believe me if I told you that AI systems are also capable of creating artistic images and soulful music? Yes, you heard it right. There is a computer program called Aaron which creates original artistic images. And similar to Aaron, Amper is an artificially intelligent music composer, producer, and performer, and is the very first AI to compose and produce an entire music album. Now it's time to look at some of the top languages to implement artificial intelligence. Python is considered to be in the first place for AI related projects due to its simplicity and huge community. Python also provides many frameworks for AI and machine learning such as TensorFlow, Theano, Scikit-learn, and Keras. Next in line is R. R is an extremely effective language for analyzing and manipulating data. It is a Turing-complete language, which means you can implement anything which a Turing machine is capable of. R also boasts of a huge community and provides more than 10,000 packages. Then we have Lisp. Lisp is one of the oldest and the most suited languages for development in artificial intelligence. It was created by John McCarthy, the father of artificial intelligence, in 1958. Lisp is capable of processing symbolic information quite effectively. It is also known for its excellent prototyping capabilities and easy dynamic creation of objects with automatic garbage collection. Now let's head on and understand what exactly is deep learning. So deep learning is a field where we implement algorithms to mimic human brain. Or simply put, we teach the computers how to learn. Let's understand deep learning with this example over here. I'll show you a set of three objects, a car, a flower, and a bird, and ask you to identify which of these is a bird. It would be very easy for you to identify the bird out of these three objects, wouldn't it? And why is that? It's because over the course of time, you would have seen thousands or even lakhs of birds, and you know that every bird has some common set of features associated with it, such as it has wings, it has a beak, a pair of eyes, and so on. And your brain has learned all of these features by example. And whenever you come across anything with similar features, you can easily identify it as a bird. That's how a brain functions. But what about a machine? What if I feed the same set of three objects to a machine? Will it be able to identify which of these is a bird? So this is where deep learning comes in. The machine will be fed numerous images of birds so that it learns all the features associated with the bird, and this is nothing but learning by example. So when the machine is fed image of a new bird, it is intelligent enough to tag it as a bird on the basis of all the learning it has done. And this is how deep learning works. Now it's time to learn neural networks. We already know that deep learning is the field where we implement algorithms to mimic human brain. Now the question that arises is, how do we mimic human brain? To answer that, let me ask another question. What is a brain composed of? So a brain is primarily composed of neurons, isn't it? And these neurons send and receive electrochemical signals. So we have an image of a neuron over here, and the electrochemical signals are received through the dendrites. And these signals are processed in the cell body and they are passed on to other neurons through the axon. So if our task is to mimic human brain, all we have to do is create artificial neurons, and these artificial neurons work the same way as biological neurons. Now we know that biological neurons keep on passing the electrochemical signals from one neuron to another, building up the neural network in our brain. Similarly, when we combine multiple artificial neurons together, we get the artificial neural network. So let's head on and learn TensorFlow. TensorFlow is an open source library developed by Google which helps in building deep neural networks. And in TensorFlow, data is represented in the form of tensors. These tensors are basically multi-dimensional arrays which are fed as input to neural networks. Then we have tensor rank. Every tensor has a rank associated with it. So if a tensor has just one element in it, or in other words, if it just has magnitude and no direction, then its rank will be 0. If a tensor has magnitude and direction in one plane, then its rank will be 1. Similarly, if a tensor has magnitude and direction in two planes, then its rank will be 2. And this goes on higher up the order. Now, TensorFlow, as the name states, is a combination of two words, tensor and flow. Here, the data is stored in tensors, but the execution is done in the form of a graph. In this computation graph, all the mathematical operations are depicted inside the nodes, and all the tensors are represented on the edges. And the entire execution process is done in two stages. In the first step, code is depicted onto the computational graph, and in the second step, a new session environment is started and the graph is executed inside the session. Now, let's go ahead and implement TensorFlow. So we'll be working with the Jupyter Notebook. So let's head on to Jupyter Notebook. This is Jupyter, guys. Our first task would be to import the TensorFlow package. Let me do that. I'll type import TensorFlow as tf. Let me run the cell. So we have successfully imported the TensorFlow package. Now there are three basic programming elements in every TensorFlow code, and those are constants, variables, and placeholders. So let's learn all of these. We'll start with constants. Now we'll look at the different types of constants over here. So the first is integer constant. Then we have floating type constants. We also have string constants. Then we have Boolean type constants. Right now, let me change the names of all of these. Let me name it to be con2, con3, and con4. Let me run the cell. So what I've basically done is I have created 4 constants onto the TensorFlow graph or the computation graph. Now, let me print these. Right. So the first constant is a tensor of type integer. The second constant is a tensor of type float. The third constant is a tensor of type string. And the fourth constant is a tensor of type Boolean. Now see that we do not have the values yet, and that is because we have not yet executed the graph. And to execute the graph, we need to create a session object. So let's go ahead and do that. So I'll say ses is equal to df dot session. This is how we create a session object. Now it's time to run those constants inside the session object. So I'll say ses dot run of. I'll give all the constants one by one. So con1, con2, con3, and con4. Right. So first constant with value 3, second constant with value 3.23, third constant with value Sparta, and fourth constant with value false. So this is how we create and run constants. Now let us look at some operations with these constants. So we'll just look at some basic operations such as addition and multiplication. So let me start off with addition. So let me create the first constant over here. and I'll give the value of 50 to the first constant, and I'll create another constant, and I'll give the value of 10 to the second constant. All I need to do is give the plus symbol in between the two constants that I'm creating. Similarly, let me multiply these two constants. So all I'll do is I'll remove the plus symbol and replace it with the asterisk symbol. Right. Again, the value or the name of this constant needs to be multiplication. Let me run the cell. Since I have already created the session, let me use the same session here, and I'll remove these earlier created constants and replace it with addition and multiplication. Right, so 50 plus 10 equals 60, and 50 into 10 equals 500. So this is how we add and multiply two scalar objects. And since we know that tensor can also be of higher dimensions, that is, we can also give in vectors or matrices to these operations. So let's go ahead and do that now. So what I'll basically do is I'll replace these scalars with vector. So let me say this vector consists of numbers 1, 2, 3, 4, and 5. Similarly, let me replace the second scalar with the reverse of those numbers, that is 5, 4, 3, 2, and 1. This was addition. Similarly, let me multiply these two vectors. So over here, I'll have 1, 2, 3, 4, and 5. And the second constant would be a vector comprising of values 5, 4, 3, 2, and 1. Let me run this now. Let me also run the session. Right, so I have two arrays over here. First array is the result of addition. Second array is the result of multiplication. Now when I add 5 plus 1, I get 6. When I add 4 plus 2, I get 6. So this is the entire addition result. Similarly, when I multiply 5 with 1, I get 5. When I multiply 4 with 2, I get 8. When I multiply 3 with 3, I get 9. So these are some basic vector operations. Now let's look at some string operations. So let me create a string str1, and let me give the value of I love a space, and then let me create another string here itself. I'll name the string be str2, and I'll type Tensorflow over here. Now let me run this inside a session. So I'll say ses.run of str1 plus str2. Now let us see what happens. Right, now we can also add these two strings inside a session, and we get the result, which is I love TensorFlow. So these are some basic operations with constants. Now we'll go ahead and understand placeholders. So placeholders are basically a promise to give the value later on. So let me give a basic example to understand this. So I'll say A is equal to df dot placeholder of. So we give the type of the placeholder. Now I'll just give it to be an integer. So int 32. So A is a placeholder to which I can give an integer value later on. Now let me give another option over here. So B is equal to A cross 2, and let me run this now. So what will happen is whenever I give the value of A, this will be multiplied by 2 and the value of B is given. Now let me run A and B inside a session. So I'll say ses dot run. Now we need the result, which is B, and we need to give the values of A, and we can do that using a dictionary. So A, and I'll give the value of 5 over here. Let me run this. Right, so we get the value of B, which is 10. So that is when we give the value of 5, to A, the value of B is 10. So A is 5, 5 cross 2 is 10, which is stored in B, and we get the value of 10. Now again, since it's just a scalar value, we can also give a vector value to this tensor. So let me give 1, 2, 3, 4, and 5. Right. So 1 cross 2 is 2, 2 cross 2 is 4, 3 cross 2 is 6, 4 cross 2 is 8, and 5 cross 2 is 10. So this is the result of P when we give this vector. So these are placeholders. Now let me actually give a placeholder for a string as well. So what I'll do is I'll create a string placeholder and I'll name it to be str underscore name, and let me create the placeholder, and this will be string. Right, and let me give another string variable over here, name1 is equal to, and let me just type I am and give a space and add str name to this. I'll run this now. Again, similarly, I'll execute this inside a session. Right. So now the result would be name1, and I need to give a name to str name placeholder. Right. So let's say my name is Sam. Let us see what the result is. Right. I get I am Sam. This I am plus str name, which is Sam. So I am Sam. Now let me replace this with a vector again. So let us see what do we get. So the first string is Sam, then I give Bob, then I give Julia, right? So I get an array with three strings. I am Sam, I am Bob, and I'm Julia, right? So this is the concept of placeholders. Now it's time to understand variables. So variables, as the name go, they can change their values. So let's create a variable and I'll name it to be var1. So var1 equals tf dot variable. Now this v over here is capital. You need to keep that in mind. So tf dot variable, and let me give the value of 30 to this. Right. Now we need to note that whenever we are creating variables, they need to be initialized. And to initialize, we will be using this function. So we'll just say tf dot global variables initializer, and we can invoke all of the variables first, and I'll store this in init. Now we also need to run this inside a session. So I'll say sys dot run of init. And this way we have initialized all of the variables first, and then we can go ahead and run the variables inside the session. So I'll say sys.run of variable 130. Now since the value of variables can be changed, let's go and update the values. So I'll say updated is equal to tf dot assign of var1, and I'm changing it to 31. So initially the value of var1 was 30, which I'm changing it to 31, and I'm storing the result in updated. Right. Now let me go ahead and run this. So this will be this.run of updated, and we see that the value is updated, which is 31 now. Now let's also go ahead and create a linear model. So let's just say the linear model is wx plus b. So let's go ahead and create this linear model. So where w is a variable X is a placeholder and B is a variable again. So W is equal to TF dot variable of, let me give a value of 10 to this, and this will be of integer type. So TF dot int 32, and then let me give the value of B as well over here. B's value will be 5. This is an integer as well. Now let me create the value for X. Since X is a placeholder, I'm going to change this to a placeholder, right? Since placeholder just takes the type of it, so the type is integer again, right? Now we'll run this and I'll store this inside a new variable and name this to be linear model and give the equation, which is W cross X plus B. That is W into X plus B, which is the linear model, is stored in this. Now, after creating the linear model, we need to initialize all of the variables. So let's go ahead and initialize those variables. I'll name it init1 and I'll say df dot global variables initializer and initialize these. So this will be sys dot run of init1. Right. Now I'll also go ahead and execute this linear model inside the session. And since the input is X, let me give a value to this. Let me say the value of X is initially 10. Let me run this. Right, so what is happening is W X plus B. That is W is 10, X is 10, so 10 into 10 is 100, plus B, which is 5 over here, so the value becomes 105. Now similarly, let me give the list of values over here, which would be 10, 20, and 30, and let me see the results. So when the value of X is 10, we get 105. When the value of X is 20, we get 205. And when the value of X is 30, we get 305. So these are some basic elements in TensorFlow. Now we are back to our PPT, and this actually brings us to the end of the video. So let's go through the brief summary. We started off by understanding what exactly is AI. Then we looked at some applications of AI, following which we looked at different languages to implement AI. And then we understood what exactly is deep learning. And we understood how could we implement deep learning with neural networks. And finally, we understood TensorFlow and implemented some basic concepts in TensorFlow. Now, if you are interested in doing an end-to-end course, then you can join Intellipaat's Artificial Intelligence course, where you will learn different concepts like multi-layered neural networks, convolutional neural networks, recurrent neural networks, and autoencoders.
Thank you for watching the video. Do like and share it. If you have any questions, comment below and we'll respond to them as soon as possible. Also, do subscribe to Intellipaat channel so that you can keep yourself updated on the latest technologies. You can also go through other related videos in our playlist. And for more information, visit our website. Keep learning, keep improving.